there's also 4200, 6200. All that means is the old version and the new version. 4300, 4-cylinder, 6300, 6-cylinder, okay? But the book usually have both, 4200, 6200, okay, and the 4363. And I tell them, they time exactly the same. But if you're in the wrong part of the book, you failed. You failed the oral and practical because you're in the wrong part of the book.
Right.
Even though they time the same.
Yeah.
Okay? But then I'll take them to the page where, okay, just skip all of this and go to the page that says, time the Magneto. That's where you start.
That's
okay?
an internal time.
And yep, and you follow through the procedure all the way, and it takes you all the way to putting the gears on, getting it ready to put on the engine. Everything goes through the whole process. And I tell them too, so you look in here, okay, it says right here, all right, when you're putting the impulse coupling drive on, torque the adjusting screw to 18 to 20 inch-pounds.
That's not much at all.
The pivot screw, 15 to 18 inch-pounds.
15 inch-pounds is just a little bit more than hand tight.
Exactly. And that's why I say, guys, when you're doing this for your examiner, ask him, do you have a torque wrench that I can do these small torques in?
Absolutely.
And if he says, no, I'm glad you asked, just don't tighten down on it.
Yeah.
So what I do is I tell him 2-finger torque,
Yeah.
no more. And even that is more than 15, 20 inch-pounds. Even that is. It's probably close to 30, okay? But at least they're not cranking down on it.
Yeah.
And I tell him, if he sees you cranking down on it, you failed.
You know, the TGT connectors and the terminals are the same because they have that ceramic. It's 15 inch-pounds. If you go beyond 15 inch-pounds, you break that ceramic.
Exactly.
And it's I've tested it many times, and I can finger tighten it and then take a torque wrench, and that's 15.
There you go. Yep.
So it's really
very, yep.
it's finger tight and then maybe just a skosh.
Well, I'll tell them the same thing like on fuel injectors. Fuel injectors on like a Continental IO 520, for example, 60 inch-pounds. That's 5 foot-pounds. And if you're doing this, you've already over-torqued it.
Oh, sure, yeah.
And it tapers as it goes down.
Okay.
And the farther it goes down, the less fuel that fuel injector is going to inject because it doesn't have enough room to inject all of it. You see what I'm saying?
So you're really screwed up.
So you have to pay attention to what you're doing, okay? So on here, so I've got all the screws loose, and I tell them, guys, don't just jerk that thing up there. There's a wire connected to these two pieces. You got your P-lead right here, your capacitor's right there. You reach up and you grab the connection and pull it off. Don't just jerk that thing out. If you rip that wire off of that capacitor, it can't be fixed. You can't solder it back on. It ruins the capacitor. It doesn't make it work like it's supposed to. Okay? So I tell them, don't do it. All right? So if this was a 4200 series, guys, when I took this off, all of this would have stayed in here. That's the only difference on a 4200, 6200 series. Okay? Everything else is the same. All right. So I also talk about how a Magneto works. So I tell them, okay, you're using a permanent magnet, which I brought one out here, and I'm going to show a couple things. Using a permanent magnet, we're going to use that permanent magnet to induce a voltage into the primary winding. Well, that's going to turn that primary winding into an electromagnet. We're going to use that electromagnet to induce voltage into the secondary winding, and that's where our high voltage comes from. Okay, so we're actually using the permanent magnet to create an electromagnet, and that's where our high voltage comes from. Okay, so inside here, all right, I've got a coil, all right, and I'll even show them. We'll get in there. There you go. I'll even show them here. So here's your laminations of high-grade soft iron, and they need to know it that way. Laminations of high-grade soft iron. All right, and the first one wrapped around it, you can see is a heavy gauge wire, okay, and there's not very many windings, okay, you see that? Now there's a heavy gauge wire, not too many windings, see that? Then here is the secondary winding, so you can see it wrapped around there. There are literally thousands and thousands of windings, okay? So then I'll ask, okay, so is this, what kind of coil is this? It's a transformer. okay, it transforms low voltage into high voltage. So we're turning the primary winding into an electromagnet. When that collapses across the secondary winding, we get the high voltage. And I'll say, so what determines the amount of high voltage? The ratio of the windings and the speed of the collapse of that primary's magnetic field. The faster it collapses, the higher the voltage. Which is why when we were running it up there, when I speed it up, that field is collapsing faster and faster and faster, so it get a better and better spark. And that's why a lot of times on the 0320 there, if it's on low idle, it sounds like it's missing a little bit, but when you speed it up, it starts running right because it's probably got a little bit of a weak magnet in one of the magnetos. You see what I'm saying?
Yeah.
Okay? All right. So then I'll show them. All right. Here's a magnet. Okay? In fact, I've got a little washer stuck on that magnet. All right? And if I put this down in here, okay, there are 3 positions of the magnet. There is full register, and then there is neutral and E-gap. All right, so right here it's in full register, and you can see that coil. Well, make sure it's actually full register. Right there. I can't get it down in there, but you'll get the idea that you see it's stuck in there.
Yeah.
Okay, but when I go to neutral, like this, oh, I could have just turned the magnet. There we go. It'll actually fall out if I do it the right way. There we go. See there? Because I got it into the neutral position and it falls out.